Andre, welcome to the stage, the GLOSAIC stage.
Thank you for having me, Becca.
Of course. Most of you probably know who this is, but for those of you who don't, Andre is the co-founder of Nomic, and he is going to talk today about open source embedding models. So I will kick it over to him.
Awesome, thank you. That's right. All right, let's see if I can activate this screen share. Looking good. Beautiful. Becca, can you confirm everyone can see my screen?
Confirm. Yes.
Awesome. Thank you. All right. Really great to be on here, everyone. So I'm Andre, one of the co-founders over at Nomic. At Nomic, we build explainable and accessible AI systems. We're the AI product studio behind popular open source embedding models, the embedding model series Nomic Embed, and we build a data infrastructure platform, Atlas, that helps people work with large embedding spaces and operationalize lots of text, PDFs, and other things you might want to embed. So the kind of overview of this talk, and it's short, so you can't talk about how to build state-of-the-art embedding models in 15 minutes, but I'm going to highlight some key things, some key sort of reasons why we, as a open source first organization that builds embedding models, have had so much success in terms of distribution of the embedding models, and how we make sure the models are high quality when compare against closed source alternatives. So kind of the structure of this talk, I'll spend a little bit of time talking about our embedding model catalog, talking about how we think about sort of the past and future of embeddings. And then we'll also talk about a little bit some of the sort of like downstream applications of embeddings and why open source models and open models have some very unique advantages when it comes to, let's say, closed models where you can't run them on your own servers, or you can't go in and use them for large batch inference workloads, which are increasingly becoming sort of like the de facto way of interacting with embedding models as opposed to single batch inference. So a little bit about us and Nomic as an organization. So we got about 30,000 folks using us in our data data infrastructure layer for storing their embeddings and storing their data for interacting with their agents and interacting with their operationalized text PDFs. Our sort of biggest top of funnel driver is obviously our open source and community editions of our softwares. We have over 50 million downloads of our embedding models across the entire embedding model series, from our V1 models all the way up to our latest V2 and multimodal models. And all of our sort of community editions of our open source softwares have over 250,000 monthly active users. So to put it this way, we're one of the sort of largest open source first organizations that uses open source as a driver for sort of commercialization of our products, but also has a gigantic distribution in the embedding model space. We have a big team internally focused solely on driving innovation in embedding models and improving embedding models. And we've had some success. We got a bunch of enterprises that use us in production, either our embedding models, our data infrastructure platform, and building over top of all the success, we've been able to raise a good sum of money to be able to continue this kind of work. So a little bit about embeddings in the Nomic embedding ecosystem. So at Nomic, we really think that embeddings are the data primitive that's going to be driving interactions with unstructured data modalities in the future. If in the past, we're sending we're sending all of our packets that are being sent over networks are containing various unstructured data modalities, maybe text or images or other things. In the future, computers are going to communicate semantically by passing embeddings along. They're the best way to compress meaning of lots of unstructured signal. And the reason we invest heavily in embeddings, and we believe in an embedding-centric future, is because that is basically the kind of de facto place the world is going. Every single generative AI system that gets released, every single generative AI model that's integrated in some agentic workflow generates mountains of unstructured signal. You need solid ways of compressing and storing that signal and ultimately operating over top of it. In the future, computers are going to operate over embedding spaces, not over top of bytes. So a little bit about our embedding model series. At Nomic, all of our embedding models are differentiated because they're open. What does this mean? This means that the embedding models have open code, open weights. So open code meaning you can go train it yourself if you wanted to. Open weights, meaning that you can go in and actually run the models yourself if you wanted to. Usually an open license, so Apache 2 or something less restrictive. And also, more importantly, open data, the secret sauce for getting embedding model training actually working. So we released our first embedding model in our sort of open series about 1.5 years ago. with really great sort of, like, kind of say, community reception. I think in the first month we got something like 5 to 10 million downloads of the model. These are kind of V1 and V1.5 models. What are sort of papers and research that back up sort of the methods that we use to improve, to create these models, make them state of the art. I have over 100 citations now in just the past year. We've expanded since our embedding model series past just text to images and multimodality, things like PDFs. The models are aligned across spaces. You can use text to search over images, images to search over text. And actually, a little bit more recently, we've been releasing some models more oriented towards tasks that code agents might be able to do, like code embedding models, with some great results and great community acceptance. One thing I'll say here is our research team works heavily on creating models that aren't just powerful and that just don't just have top metrics on the leaderboards, but are actually operationalizable for production use cases. What does this mean? Is that you don't think about, how do I get the highest quality performance out of my model by, making it 10 billion parameters, 100 billion parameters, but how do we go about and find that right balance between operationalized production workloads? I need to generate 1 billion embeddings. I need to be able to do that without breaking the bank. And downstream properties that you might care about in embedding models, like compressibility. I need to store 1 billion embeddings. Storing 1 billion embeddings is actually very expensive. That's terabytes and terabytes of data. But if you design an embedding model from the ground up that takes into account things like post-training quantization, you can bring down that cost a lot, for example. The impact of our work here is kind of well known in the research community. We have top papers accepted at venues like iClear, EMNLP, TMLR, etc. If you want to find out a little bit more about our research side and sort of how we kind of what the secret sauce is to getting state-of-the-art embedding models that work really well and that are really research efficient, you can hop into our research page, nomic.ai/research, for kind of a deep dive into all the papers and all the sort of training methodologies that we use internally. But what I really want to focus on here is why the impact. And this is, I think, kind of the most, let's say, useful advice I think we can give in terms of what does it mean to actually make impact as an organization that is, relatively smaller. We're much smaller than, let's say, other labs that are producing, state-of-the-art models. And how do you actually have impact in the space when you're working under those constraints? Why the impact of our models? Well, number one, we were at various intervals, and as everyone knows here, every month there's a new model that's topping the leaderboards. We were one of the first fully open source, open code. We were the first fully open source, open code, open training data model to beat OpenAI's top embedding model in early 2024. This is the time was OpenAI ADA. So we had an open source model that was about 135 million parameters. That was actually beating OpenAI's models on metrics. And we openly released this for anyone to use. This has sort of kind of created a big sort of paradigm shift in terms of how people thought about the cost basis of embeddings and how people thought about using embedding models in downstream applications like retrieval, RAG, injected calls, that sort of thing. And I'd say the other biggest thing when you're going around and thinking about, how do you actually have impact with models that you're training and producing, especially when you're open sourcing them, is thinking about practical applications from the start, not after the model's been trained. How do you incorporate downstream properties that you might care about, like compressibility for efficient storage, quantization for efficient, let's say, search and retrieval, into the research and engineering phase of designing the model, designing the learning objectives for the models, and ultimately the data mixes for the models? Do people really want a 7 billion parameter model to run retrieval queries? Turns out that's actually overkill for a lot of tasks. Not all of them, but a lot of tasks that it is overkill. And most importantly, if you think about if you think about a world that every single log message in your ClickHouse database and every single document in your coming out of your Kafka stream is going to have an embedding associated with it, how do we make sure that those embeddings are useful ad infinitum? How do we make sure that new embedding models are compatible with the embedding spaces of old embedding models so that you don't have to re-embed gigantic corpora every single time you want to run vector search operations? We think very deeply about these sort of questions at the research phase, not the post-research phase. This is the other reason our open source models have a lot of impact. The last thing I'll say here is that, starting out, we were a smaller lab. We only had access to a couple dozen H100s at the beginning. This caused us to actually be really innovative on the stuff that matters, focusing a lot on code and kernel optimizations to reach large batch sizes to be competitive with training techniques at the time. This is kind of commonplace now. We open source a lot of the code for it. but at the time it was non-obvious and how to reach gigantic batch sizes without having gigantic clusters for things like contrastive training, and then also focusing on higher quality data. If you do one thing when you're going in and building ML models, you need to make sure that you focus on making sure your data set's high quality. Tinkering with the parameters is much less value add than working on the underlying data. For example, when we were training our V1.5 models, it took about 9 months from kind of start to finish of that entire project. For the first 7 months, we literally just stared at data sets the whole time, and then for the last 2 months, we actually did some training runs and stuff like this. The point here being is that data is the secret sauce. Data is the reason models are high quality. But this is also the reason most people don't release their data sets. By taking a kind of a truly open source approach to model building, you can also have much larger impact in the open source space. And this is sort of just some vanity metrics showing off. I think we're the top embedding model on Ollama. I think they were at the previous group here. Whenever you run RAG with Ollama, you're probably using our Nomic embedding model, and also a very high distribution on Huggingface as well. Inference layer stuff is also really important. You got to make sure that people can run your code and not have to just run PyTorch weights. One thing I'll say here is, when you think about embeddings, you might think about retrieval use cases. What this means is you're taking in a large database of signal. So this is like maybe a bunch of PDF documents, and you're trying to run a query to figure out the right PDF documents to put in context into your language model. That's only one use case of embeddings. In a world where embeddings are dominating, every single data store and every single data lake, there's many other operations you want to be able to do in embedding spaces that allow you to do very interesting and complex tasks that sort of lower the barrier to entry to things like data analysis and agents to be able to run sort of complex operations over your data stores. One thing I want to highlight is, our embedding models are open source, but our product and sort of the way we make money at Nomic is actually building a data infrastructure platform that's embedding native. It's called Atlas. It helps folks operationalize millions of embeddings of text documents, PDFs, images, and work with gigantic data sets of text. Some of the cool things we do there is we've implemented and actually built from scratch an embedding native data layer based on common data formats like Apache Arrow and the newest one, Lance, actually. Really great. I think they're actually part of this conference here. And this allows for querying and working with gigantic data sets of embeddings in a data lake format that's kind of universal. We built sort of a custom graphics engine for visually analyzing embedding spaces. And then, embedding models are just part of the secret sauce. There's lots of other embedding space algorithms like topic models, dimensionality reduction algorithms that come out of our research team that allow folks to have really powerful interactions with embeddings. I'm going to run one quick demonstration here of just what I mean by this. So I'm going to pull up a data set here, actually, these are text embeddings of a data set of customer reviews. So every single point in this view is a 2D reduced version of that embedding space. 2 points are close together if they're talking about the same thing. And I'm actually going to grab a slider and create a multivariate time series over top of this embedding space. So what you're looking at here, as I slide this slider, is actually a time filter over top of the model's embedding space that allows you to see sort of trends and topics and interesting properties emerge in the underlying data set, of this case, airline customer reviews. One cool thing you can see here is as I slide this slider, I hit this region where we have a high density in the embedding space over top of April 20th and November 2020. I'm actually going to go in and I'll grab that and be like, hey, what is this? So you can actually go in and with Atlas really easily interrogate regions of your data set. And in this case, it seems like, this multivariate time series caught the fact that lots of airline customer reviews were having issues with COVID. These are the kind of insights you can have when you're sort of operating over embedding spaces as a whole, as opposed to making point-wise vector search queries. So really powerful stuff. And we think very deeply about how do we enable the next generation of applications and use cases of embeddings, particularly with our open source models, but supporting any sort of model. Other cool demonstration I want to show you here, this is embeddings coming out of a MNIST model. So this is a model trained to classify digits. Every single cluster here is a digit, so this is a 0, and a model is predicting whether or not the image is a 0, 1, all the way to a 9. One of the other powerful things you can do when you have tooling to work with your embedding spaces is look at, say, decision boundaries of models. So every single point here on a boundary is actually places where models are making errors. So in this case, if you look at this example, what's happening is that the image is being misclassified by the model, but you can visualize that and interactively inspect it by being able to use tools like Atlas to be able to look at your embedding space and to work with your embeddings. In this case, the model actually at a given checkpoint is predicting a 0 for this image when the actual label is an 8, and you can see why, right? This is clearly a hard negative example. So anyways, this is how we think about embeddings, and this is how we think about the future of embeddings and where the world is going. We invest heavily in open source, and we will keep investing heavily in open source because it works. Ultimately, as I said, every single piece of data in the world is going to be embedded, and we're going to make sure that we power every single embedding in that world. So really excited to be able to talk to you guys a little bit about embedding models and how to work and produce open source state-of-the-art embedding models, and a little bit about the sort of future of embedding model tooling. If anyone wants to connect after this talk, you can add me on LinkedIn here. Happy to kind of dive deep and have any conversations about our models, answer any questions about our sort of newest models, our code and multimodal embedding models that allow you to do things like retrieve over large data sets of PDFs and images and screenshots. And in general, really just thank you for your time here.
Awesome. Thank you so much. That was amazing. Really appreciate you making time to join us today, Andre.
Thank you so much.